Hello everyone, hope you are doing well. Today we are gonna talk about problems related with piston. So we'll start with solving a problem. Here temperature is constant and a piston is provided where we have a stopper in the middle. On the left side we have helium, on the right side we have neon gases. When the stopper is removed and equilibrium is attained, find out displacement of piston and find out pressure in each compartment. So we'll solve this problem. First we'll write that after stopper is removed, what will be the situation. We'll draw the diagram for that. So here I'll quickly copy this diagram and draw the condition when the stopper has been removed and equilibrium has been attained. So the stopper would have moved some distance, let's call it x. So the new distance here will be 40 plus x and the new distance on the right side would have been 60 minus x, right? So on the left side we had helium, on the right side we have neon. This is the x distance by which the stopper has moved on the right side. Here helium will be present at P atm and neon at some P atm. Okay, we'll apply Boyle's law. Because temperature is constant, we can apply Boyle's law for helium. So what is Boyle's law? It is initial pressure multiplied by initial volume should be equal to final pressure multiplied by final volume, right? So volume here will be area times length. Area is pi r square, which will be same, so it will be cancelled out on both sides, only length will matter. So we'll put the value of initial pressure and volume, which is 10 multiplied by a multiplied by what was the length, it was 40, is equal to final pressure, which is p, multiplied by a multiplied by length, which is 40 plus x, right? So we'll solve this equation. We'll get that 40 plus x or p multiplied by 40 plus x is equal to 400. So this will be our first equation. Similarly, we'll apply the Boyle's law for neon gas. So we'll write Boyle's law for neon gas. Here again we'll apply initial pressure multiplied by initial volume should be equal to final pressure multiplied by final volume. Putting the values, what is the value of initial pressure? It is 4. Initial length, it is 60. So 4 multiplied by a multiplied by 60 should be equal to the new pressure, which is p multiplied by a multiplied by new length, which is 60 minus x, right? So p multiplied by 60 minus x should be equal to 240. This is the second equation. Now we'll solve these two equations. How do we solve it? Simply divide it. 1 divided by 2. What will we get? 40 plus x divided by 60 minus x is equal to 400 divided by 240. On solving this, what will we get? It will come out to be 10 by 6, which is 5 by 3. On further solving, we'll get the value of x. So 120 plus 3x is equal to 300 minus 5x. So 8x will be equal to 180, right? So x will come out to be 22.5 centimeter. Similarly, we'll solve for the value of p. So put this value in equation number 2. So p multiplied by 60 minus 22.5 should be equal to 240. On solving, we'll get the value of pressure. It will come out to be 6.4 atm. So this is the answer. Hope you understand. So we got the value of displacement of piston as well as the pressure in each compartment. Now we'll discuss about second method to solve this problem, which will directly give us the final pressure. So we'll write P final is equal to summation of Pi Li divided by summation of Li. I represent the ith gas here. Here it is helium and neon. So final pressure should be equal to here Pi Li, which is initially what's the value of pressure and the length. So we got 10 multiplied by 40 plus for neon we got 4 multiplied by 60 divided by 40 plus 60, right? So we'll solve this and we'll get 400 plus 240 divided by 100. It will come out to be 6.4 atm. So this will directly give us the final pressure. So you need to remember this formula. It's very useful, and we can solve for x here using the Boyle's law, which is PIVI is equal to PFVF. Simply apply on any of these gases, helium or neon. I am applying here for helium. So 10 multiplied by 40 should be equal to 6.4 multiplied by new distance, which is 40 plus x. And on solving this equation, we'll get the value of x and it will come out to be 22.5 centimeter. So this is the answer and this is the simple formula. Now we'll solve an interesting problem. Here we have two stoppers. Temperature is provided constant. Helium, argon and neon, three gases are provided with their pressure as well, and the lengths they are occupying here, and When stoppers A and B are removed and equilibrium is attained, determine the final pressure in each container when both the stopper has been removed and displacement of each piston from either piston. So pause this video and solve yourself. So I'll simply solve it using the formula which we discussed earlier. The final pressure should be equal to the summation of product of initial pressure into length divided by summation of initial length. So 10 multiplied by 25 plus 30 by 7 multiplied by 35 plus 5 by 2 multiplied by 40 divided by the total length, which is 25 plus 35 plus 40, right? So simply we'll solve this and we get the final pressure which will be present in each container. So it will come out to be 500 divided by 100, which is 5 atm, right? Now we'll solve the second part, which is displacement of each piston from either pistons. So for this we'll have to draw this diagram again and draw the condition when the stopper has been removed. Okay, so these will move by certain distances. Let's call these distances x and y for stopper A and B. Here we have helium, argon and neon. The pressure in each compartment will be P, which we solved here. So helium compartment has moved by x distance, argon compartment has moved by y distance, right? So these are the displacement of the stoppers respectively. So the new length here will be 25 plus x, right? And this is for helium. And for neon, what will be the new distance? Earlier it was 40, so new distance will be 40 minus y, because y distance has been removed from the neon section. And these were displacement y and x for argon and helium respectively. Here the pressure in each compartment will be P, which we calculated earlier, which is 5 atm. So we'll write Pi Vi is equal to Pf Vf. We'll solve this for helium. So applying this formula, initial pressure multiplied by initial volume, what it is? 10 multiplied by 25, area is constant, so we'll ignore that part because it will be cancelled on both sides. 10 multiplied by 25 should be equal to P multiplied by 25 plus x. Putting the value of P, 5, we'll get the value of x. So on solving, x will come out to be 25 centimeter. Similarly, we'll solve for y. So we'll apply Pi Vi is equal to Pf Vf, which is Boyle's law for neon gas. You can also apply for argon gas. I'm applying for neon gas to simplify it. Now solving further. So Pi Vi, it is 5 by 2 multiplied by 40 should be equal to 5 multiplied by 40 minus 5. 5 is the final pressure. So on solving, we'll get the value of y. It will come out to be 20 centimeter, right? So we got the displacement of each piston from either piston, right? When stoppers A and B have been removed. Okay, so we solved both the parts. Hope you understand this. It was very interesting problem.